So in section 5.5, this section is law of signs. And so this is where we can use sign for non-right triangles. So at the top of our page, we're going to write our law of signs. And this you can write on your identity sheet. It is on the identity sheet that I gave you for the test as well. So if you have that printed one that I told you you could use for the test, that's already on there. But we are going to do law of signs. Okay. Now it has 3 parts, and we will not use 3 parts every time, but it's important for you to know all the 3 things are true. So we've got sine of big A over little a is equal to sine of big B over little b, which is also equal to sine of big C over little c. This is kind of geometry. I don't think I taught you this, but it kind of is geometry. So make sure that you have that down. I'll see you later. Okay, so what happens is we'll usually just use 2 of these at a time. So usually we'll just look at like A and B together and we'll set that equation equal. You might do A and C and ignore B, but you'll only have 1 equal sign at any one time. So even though there's 2 right now and it feels like a lot, it will all work out in the end, okay? So this is the formula that we're using on the next few problems. On the formula sheet from the test, it actually has them switched. So it doesn't matter where you put one or the other as long as you're consistent. Do you have the sides on top or do you have sine of the angle on top? Either way, doesn't matter to me, okay? Now on the following problems, it says solve. When it says solve the triangle, it means it wants all 3 angles and all 3 sides. So I actually might start all of these problems by kind of making myself like a little box and saying, I have to find all of these pieces before I know that I'm done. And you can draw your box however you want. I'm just going to make sure that I've got a spot for big A and a spot for little a and a spot for big B and a spot for little c. My best spots, but it'll do it. So big A, big B, big C, little a, little b, little c. Can anyone remind me which one of those is my angles? Are the big letters or the small letters my angles? The big ones. The big ones are my angles. And then the small letters are my sides. Steal Luke's chair because it looks like we're down one. I don't think he's gonna be here. So if it helps you, these are angles on this side. And then these are sides over here. So just make sure that you're labeling it correctly and you know how to use it. Okay. Now, that being said, oh, I wrote A, B, and C and we have C, H, and S. Let's just fix those. Let's just make them A, B, and C just for today. I'll make that one can stay C, and I'll make this one be A, and I'll make that one be B. Sorry, I don't think we did that C period, but just for sake of keeping things simple. Okay, what do I already have? What's one thing that I already have? What is? Good, I've got B is 45 and I've got C is 60. Do I have any little letters? Which little letter do I have?
B.
It's gonna be B, it's gonna be across from the big letter. So I have little b is 3.7. When we do law of signs, we use sine of an angle over its opposite side. So I have got to use B in these examples. And it doesn't matter which I use A or C next, because I actually think that we can find big A before I do anything else. Does anyone know what big A is going to be? Good. Alea said 45 plus 60 minus from 180. So you're welcome to do that math off to the side. You're welcome to just put it in your calculator and call it a day. But I'm going to add those 2 numbers together, subtract from 180, and that's going to tell me what big A is. And I get 75. And so that means now at this point, I could do A or C, it doesn't really matter, but I'm going to use B for both of them, okay? So I'll set up the first equation and we'll do C first because that was given to us, okay? So I'm gonna set up the equation and we're gonna do sine of or I guess I said we'll do C, so we're basically doing like this part. So I'm gonna do sine of B over little b equals sine of C over little c. Fill in the numbers that we have, use variables if we don't. So I'll start sine of 45 over 3.7 is equal to sine of 60 over little c. Once I've done this, we just cross multiply and we solve. So I'm going to cross multiply so I can get rid of those fractions. So I get C times sine of 45 equals 3.7 times sine of 60. And then we want to get C all by itself. So I'm going to divide by sine 45. Now, just like we did earlier, at any point you can put sine 60 in your calculator, you can put sine 45 in your calculator, I don't care. And I know that these are numbers that like we might know off the top of our head, I just want you to use the calculator. But I like at the very end, putting like this expression, this whole thing into my calculator and just pressing enter once. So I'm gonna do 3.7 sine 60, and then division sine 45. And I get 4.5.
Are we supposed to be in degrees or?
Great question. What is my angle in right now? Degrees. So we should be in degrees. Great question. We'll be in degrees. Excellent. Listen. Good, so I'm gonna go back to my chart and I'm gonna put 4.5 in for my C. Now we're gonna do the exact same thing for A. We're gonna set up the exact same equation, but instead of using 60 and C, we're gonna use 75 and little a, okay? I am gonna still use B. At this point, you could use sine 60 over 4.5, but what if I mess up that 4.5 and I'm using a messed up number to get my next answer? So I always like to use the numbers that were given to us originally. So I'm gonna go do the exact same thing, but we're gonna do 75 and A. So we'll do sine of 45 over 3.7 equals sine of 75 over little a. Okay. Again, cross multiply. A times sine of 45 equals 3.7 times sine of 75. Divide by sine 45 on both sides. And then I'll put that in the calculator, 3.7 sine 75 divided by sine of 45. We get 5.1. And then that's it. We'll go put it in our box, and then I know that I'm done when I found all of my sides and all of my angles. So have I found every side and every angle here? Yes. All right, awesome. Now we're ready to do the next one. I wanted to do one example with A, B, and C to match the formula, but now we can do C, H, and S for the next two. So go ahead on this one, draw your triangle out. And at this point, I don't care what your triangle looks like. We just want a triangle so I can figure out where my C and my H and my S are. I want to have something to label.
Does it matter where like the C, H, and S thing?
As long as with H you have 30 and with C you have 40. Okay.
This is just a gentle reminder, please take attendance.
Thank you. I know, I was doing so good. We haven't had a call for a while. Oh, it's not here either. Seems also not here. I know seems here. It was extra. Oh, speak of the devil.
Yeah, sorry, this is. We're gonna get a chair. I can stand, I can stand.
You can sit at Mr. Giles' desk. Uh-huh. I think that's probably our best option. Because the other classrooms have classes in it, so. All right. Now that I've taken attendance, now that our friend Luke is here, we're ready to keep going on number 2. Do you have your picture drawn? Do you have your chart drawn? I would draw a chart so that you remember where to find all your pieces. Once you've done that, we're gonna be ready to do our law of signs. And I'm gonna need someone to help me write that one to start with. CHS. Good to remember what we have. Okay. Who thinks that they can write my law of signs? Sophia?
Sorry.
Good.
Sorry.
Set of 40 over what? Little c, perfect. So Sophia used both of her parts of H, which we need 30 and 10.8, and then she has 40, and that's big angle C, so we want to find little c from that. All right, once you have that set up, cross multiply and solve. C sine 30 is 10.8 sine 20. I want to remind you to plug in these numbers like I am, because it's gonna be really frustrating when you're like, oh, I set it all up. And if you are not practicing plugging the numbers in, you may mess up on something that you have not practiced yet. So make sure that you're also plugging, chugging the calculator just like we are. All right. All right, we're doing great so far. Anybody questions? Now we have to do one more step before we can do another law of signs. Does anyone know how I can find angle S? Yep. So I can do 40 plus 30 plus angle S, or I'll just use an X. And what is that gonna be? 110, awesome. So that's just like basic knowledge of triangles we learned back at sophomore year in geometry. We just gotta keep that in the top of our head. Gotta remember all the angles in a triangle add up to 180. Now I'm gonna do law of signs again. I'm gonna encourage you to use the H angle and side, because that was already given to us. For some reason, if we had messed up C, we don't want to use something messed up to find a new piece. Can someone write that equation for me? That's my new law of signs gonna be.
Sine of 30 over
Equals,
sine of 110.
yes, nice. And if you don't like using the variable S, I think it looks a lot like a 5. You can make it an X, you can make it whatever you want it to be. Just remember what you're solving for. You're solving for a little x when we go for it. So I'm just making it an X because too many S's is a lot for me. And then we cross multiply and we solve and we divide, and then we put it in our calculator. I got 20.3. Is that what you guys got? All right, I think you can try the third one on your own. So I will do the work silently on the board. You go try the third one on your own, draw your own picture, set up your own chart, set up your own law of signs. Then we'll check in when I have my answers out.
Search.
So as you go, you can check in with your answers on the board. Again, I'm gonna be quiet, but you can always check and see if you're doing things right. I can show my work, but there are my answers on my chart. We doing okay with that? It's pretty easy stuff, right? Okay, now I always say that and then a curveball happens, right? So are we feeling good on where we're at right now? Okay. What I'm about to teach you is still using law of signs, but it's just a different case. So something we just need to watch out for. So when you're ready, when you're done with this, go ahead and flip your paper over and notice that the next question say, how many triangles are possible? How many triangles are possible? I really just want to do these three problems and then that should be it for today. Before I move to the next page, anybody questions on what we've done so far? Okay. Now, if you can't see your law of signs anymore, I would make sure to maybe write it down at the top of the page just so that you remember it. So I'm going to remind myself we're still doing our law of signs. And in case I forgot, this is a formula we're using: sine of A over little a, sine of B over little b, and sine of big C over little c. Okay. Notice on all of the other problems, what was given to you? How many of each thing was given? So like on letter C, what was like the given information? Two angles and one side. Is that the same thing for letter B? Did we get two angles and one side? And on letter A, did we get two angles and one side? Okay, so normal law of signs, we get two angles and we get one side, okay? We're gonna do something now called the ambiguous case where I'm gonna give you one angle and two sides. So that is one kind of clue that we're gonna have to do something a little bit funny. So this is called the ambiguous case. You guys know what the word ambiguous means? Strange, it's funny, different. It's a different case. It's like kind of unknown, like we're not really sure what's happening. It's not like spelled out for us. So the reason this is called the ambiguous case is that there are three things that could be happening here. The first thing, we could have zero triangles. We could have one triangle, or we could have two triangles on here. So we are not sure what's happening. We don't know if we have zero triangles, one triangle, or two triangles. Okay. And this happens when we have one angle and two sides. Do you remember back in geometry when we talked about angle, like triangles being congruent, and we had like side, 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 and side, angle, side? Do you remember what one of the like non-examples was? Like if you got these three letters, it was not not similar triangles. ASS, very good. I knew you guys would remember. If I give you ASS, then we know it's an ambiguous case. Okay, if you know that you only have one angle and two sides, it could be a couple different things, okay? Let's just go ahead and start solving, and I'll try and show you how we know which one we have. We are given information. We're gonna start this just like we started all the other problems, okay? So I'm gonna draw my triangle. I'm gonna just draw kind of like an acute little triangle so I can put A, B, and C on there, and I'm gonna label the pieces that I have. So on this example given to us, we know B is 82 degrees, and we know little b is 17, and then we know little c is 15. That being said, what am I gonna find first? Am I gonna find big A, big C, or little a? Big A, good. So based on our law of signs, we're gonna use big B and little b. Oh, not big A, sorry, I lied. Not big A. We have big A, or big B and little b, and we have little c, so what's big C? We're gonna find big C. Big C. Because I have the side opposite it. If I didn't, I have no little a or big A, so I can't do anything with A right now. So we're gonna do our law of signs just like normal, okay? So I'm still gonna set it up like we're used to. We'll do sine of 82 over 17 equals sine of big C over 15. And we're gonna solve that out and we're gonna see what answer we get. So we'll cross multiply. I get 17 sine C equals 15 sine 82. Now we haven't had to solve like this. Normally we just divide then by the sign and we move on. This time I can't divide by the sign. I'm gonna divide by that 17, that number that's in front of my sign. So now I have sine of C equals 15 sine 82 over 17. Do you remember how we get rid of that sign that's in front of the variable? Inverse, second sign, sine to the -1, whatever you want to call it. Basically, we're doing it to both sides. So when we do inverse sine of sine, the signs cancel and we're just left with C. And now we're going to do inverse sine of this big fraction. And I can type it in just like that. I'm gonna do second sine, and I'll do 15 sine 82 divided by 17. And I can press enter. Okay, if I don't get an answer, that would be something we'd worry about, but this time I did get an answer, so everything seems good right now. So I've got C equals 60.9. I told you this was an ambiguous case and we could have 0, 1, or 2 triangles. We don't have 0 triangles. If I did not get an answer that it would be 0 triangles, we'd be done, it would be great. We either have 1 or 2 triangles here and we have to decide which one we have, okay? We could have one triangle where I've got like 60.9 degrees here. And let's actually keep going. What would angle A be if C was 60.9? 37 point what? 0.1. Perfect. So 37.1. Does that make sense in a triangle? Would we all be cool with that? Yeah, okay. What could happen with this ambiguous case though is instead of being this cute little acute triangle, it could be like it could be like this. Let me draw a little bit better. It would be like an obtuse triangle. Okay, there we go. That in this case, it would still be A, B, and C, but it would be 15, this would be 82. And then instead of angle C being that 60.9, it would be the supplement of that. Do you remember the word supplementary in geometry? What does that mean? Add up to 180, good. So if 60.9 and its supplement, the supplement would be whatever 180 minus 60.9 is. And so 180 minus 60.9, that's 119.1. If we had 2 triangles, then I could put 119.1 in for C, and that would make a triangle. Would that make a triangle here? Why not, Alea? It's not 180, right? Already 119.1 and 82 is already more than 180. Is there any angle left for angle 1? No, like that's just not a possible triangle, so that will not work. So we have to check its supplement. So if you see how many angles it's possible, if we get an answer, then we have to check the supplement. And I'm gonna use the word supplement, but I'm gonna write 180 minus my angle. That's gonna be like kind of my note to myself. If we get an answer, then we have to check and see if its supplement works. It then says solve the triangle, and at this point I have all of it solved except for side little a. Can we just use our law of sines formula to find little a? Okay, let's go do that. So I've got, and I'm gonna keep using b, I'm gonna use the sine of 82 over 17, and then I'll do sine of 37.1 over little a. And then this is just like the front side of our paper where we just cross multiply and solve, and it should be a very easy solve. I got 10.4. And for this one, we could have also drawn a like chart to like make sure that we had all the pieces, but I think just labeling the picture is enough for right now. All right, we feeling okay about that? Okay, so that was an example of where we only had one triangle. So I may write that off to the side, one triangle for letter A. Let's go find out what letter B is. So we're gonna do the exact same idea, draw our picture, see if we can set up our law of sine like we're used to. All that fun stuff. So I've got my picture drawn, we're gonna do our law of sine. Which variable am I finding now? If I have big A and little a, and I have little b, which variable am I finding? Big B, very good. Sine of 73 over 24 equals sine of b over 28. So I get 24 sine b equals 28 sine 73. And then just like we talked about a minute ago, in order to get that big B by itself, we need to divide by 24 and we need to do our inverse sine. I know it's kind of like all crammed in here, but I'm gonna come over here to the side and write inverse sine of 28 sine 73 over 24. And then I'm gonna go ahead and plug that just right in the calculator. Second sine 28 sine 73 divided by 24. And then I got this crazy answer. See what you get in your calculator. So I think it should just be, did anyone just get error? Yeah. No, I think I did it right. Supposed to be an error. It should be something funny. I just want to know what does your calculator say? Does it say error?
Yeah,
Mhm.
domain.
Domain, like it gives you an error message and says something that's wrong. Yeah. So when you plug it in and you get something wrong, like if it pops out for an error message, then I know that there's no answer for B. Like B does not exist.
So that means
That means that there's no triangle. There are 0 triangles for letter B. If you get an error message, which can happen, it just doesn't exist. Now, we're gonna do the last one. What do you think the answer is gonna be for the last one? If we've had 1 triangle, we've had 0 triangles, you think we're gonna have 2 triangles, right? So we're gonna set it up just like we did letter A, we should get an answer, and then we're gonna check its supplement, okay? So I'm gonna be quiet, you draw your picture, you do the first setup, see if you can solve that out, see if you can get the first answer right, and then we'll go from there together.
That's right. Yeah. I can still do sign A if they sign C.
Even though the formula goes A and then B, is that what you're asking? Yep, you can just take B out and just go directly A and C. And so you should have gotten to the point where you get what big A is. Which is what I got. Since we already knew that we were probably gonna have to do 2 triangles, you should already kind of have in your mind that we're gonna do this 2 times. Thank you. Okay, so I'm gonna come up here, I've got 72.5. Now, I was trying to be intentional about how I drew this triangle, because, I think that this is gonna be as good of an explanation as I can draw, on this picture. We know that we have, this side is 10, this side is 18, this side is 32. We're saying one option is that my angle over here is 72.5. My other option is if I, instead of having that be an acute angle, it be an obtuse angle, and then this is 10 right here, and then this is that supplement in that point. The reason that works is this is an isosceles triangle, and if this angle is 72.5, then this angle would also be 72.5. So then the obtuse angle next to it would just be whatever its supplement is. So that angle right there is gonna be 180 minus 72.5. So I can find what that is really quick. And that's gonna be 107.5. I know it's all kind of crammed in there, but now I'm asking, does this little obtuse triangle, if I like pretended like none of this existed right here, and I'll erase that in a second, but if this obtuse triangle that you see right there, I'm asking if that's real. So I'm asking now, if we did 107.5 plus 32 plus something else, would we have enough for 180? And we would say yes, because whatever 107.5 is plus 32, that's smaller than 180, so like I still have room for another angle. So we're gonna say we have two triangles here. So this one is a 2 triangle. Because we checked the supplement and it worked. Like that's an okay triangle. I can erase that messiness if you like kind of that explanation.
So basically, all we do is 180 minus.
And we see if we can still have a triangle there. And like, we can even find out what would that angle be. So like that, like kind of empty box that I've left there as kind of like a hold in space. If we did 180 minus that 139.5, then that angle would be 40.5, and that's an okay angle for right there. Okay. Now, it does want us to solve this triangle, so we need to find those missing sides. I think it's little b we need to find, and we need to find it in both of the triangles. So we're gonna do 2 more lob signs, and then that's gonna be it for today. What we would do on the, actually, let's go to the second triangle because we've been focusing on that. I've got my 40.5, so I can do sine of 40.5 over little b. And then I would probably use the pieces that were given to me, which is 32 and 10. So I would do sine of 32 over 10. I always like to go back to the beginning. What are 2 sides that were given to us to start with? So we'll do b sine 32, 10 sine 40.5, and then divide by sine 32. I get 12.3 for this little triangle. And if you notice, and I know there's like a lot going on up there, but that little obtuse triangle, every angle is labeled and every side is labeled. Now we have to go back to the original triangle, the normal one. Before I solve anything, can we figure out what goes in for angle B? Is that what 180 minus 32 minus 72.5 is? Perfect. And then from there, we can find little b, do our
So
loss.
do we have to do what last if we just did?
So if it says solve both of the triangles, then yes. And it does, this direction does say solve it. What I will probably do is just ask how many triangles are there? Which is almost solving all of them. It's just not this last step of finding all these little b's. So I need to do. I need to do sine of 70 or 32 over 10. Equal sine of 75.5 over b. That got messy, sorry. Sine 75.5 divided by sine of 32, and I get 18.3. Cool, and that's it. We've got a couple word problems that we'll wait for tomorrow, so I won't assign any homework now. If you have anything that you want to turn into me, let's get that in. If not, you have another day off of pre-cal, and I'll see you tomorrow.